Hello, everybody. Welcome to Physical Science today.
What's physical science?
Physical science is the study of the physical universe. At this level, it's the introduction to chemistry and the introduction to physics. So we've been talking about atoms, which are made up of protons and neutrons in the nucleus, surrounded by a cloud of probability where you may find electrons. Protons and neutrons are made out of quarks. An electron is a fundamental building block, they say, just like a string is now. So yeah, quark is, there's 3 quarks in each proton and neutron. So yes, they're smaller. And now they're saying that there's a particle that makes up quarks that might be called a string. And that would be a fundamental particle, just like they say the electron is a fundamental particle, which they mean that is maybe atomos, which means indivisible, right? So he was wrong in the beginning, but he was right because he started talking about it. And he said the atom was indivisible. He was wrong. Okay, so when we look at our new notes here, then we're going to talk about the periodic table, how it's set up, and how it has trends in it. So the periodic table of elements, and these elements are formed in stars, or when stars are made, or when stars are destroyed. So all those things smash smaller particles together, such as hydrogen and helium, and when we get more and more things smashed together, and they coalesce, or they come together as one thing, then we get bigger and bigger atoms. So everything that we're made of, so you could actually say you're a star child, because according to this theory, everything is made out of stardust. Okay? So that's the current theory, is that all these atoms, different types of elements are made in stars, or where stars are made, which are nebulae, or when stars burn out. Okay, so Mendeleev was Russian, so there's a little history for you. He first started looking at these trends in the periodic table, or he started making the periodic table by looking at the trends that occur in different atoms. And so he thought, like, one thing acted like another thing, so he grouped them together. And he recognized, so what he did first, his first idea was, however much mass they had, that was how we were going to start to split them up and get them in groups by their masses. And then what he found was repeating patterns every 8 elements by their mass. So put all the elements in a row by their mass, and every 8 element he had elements that acted like the one that was 8 before, and elements that acted like the one that was 8 after. So he started coming up with this idea that every 8 element is going to be similar. But he was wrong. Because he was able to predict some things, but he noticed that he did have some flaws. He started seeing the flaws in cobalt and nickel, among other things. So what happened was, his idea was pretty good, and like all people in the beginning, you have to start, right? Like the first person to raise their hand and give out an answer in class has to start and has to not worry about being right or wrong. Because if you don't start, you never finish. So he's like a founding father of the periodic chart. Mendeleev. Okay, so then this guy named Moseley, in 1914, so it's not that long ago, like 100 years ago, which isn't very long. He rearranged the elements in a different pattern, and the pattern that he used was by their atomic number. So you guys remember what the atomic number is? The number of protons. And if you remember what we talked about before, the number of protons is like the identifying number. Like, the number of protons is what determines what we have. If we have, 3 protons, we always have lithium. We could have, maybe 2 neutrons or 3 neutrons, and still have lithium, but if we have 3 protons, it's always lithium. If we have 8 protons, what do we have? Oxygen. Always. And then we can have different numbers of neutrons, but it's the protons that really determine what element we have. Remember, protons are just a massive particle that has a positive 1 charge. Electrons are very small, like insignificant massive particle. But the significance is it has the exact same electric charge, but opposite to the proton. So an electron is -1, protons +1. So he did it by atomic number, and he was right. So the periodic law then comes from the combination of these two guys. The periodic law is chemical and physical characteristics of elements are periodic of their atomic numbers. Okay, so period is a row of elements. So if you look at our periodic table here, we have one down here, and you guys have your own periodic table. But these would be the periods right here. So it's kind of hard to see, I guess, on the very edge here, but see the number 1, the number 2, 3, 4, 5, 6, 7. So there are 7 periods in the periodic table. Look on your periodic table, make sure you have those 7 periods marked on your own periodic table. If not, then mark them in. Okay, so the way that this works is you have period 1. Period 1 is right here. Look, there's only 2 in period 1. So we have hydrogen and helium. And that makes up the whole first period. Okay? Period 2 has lithium, beryllium, boron, carbonate, oxygen, fluorine, and neon. So that has 8 elements. Period 3 8. And then we go on and we'll talk about parts of this table. But this part, these first 2 columns here, and they're also referred to as families, up and down. And then these 6 columns over here. Okay, so it's kind of hard to see without these colors. But right in here, including this stuff down here, with the exception of those things that I highlighted in the red, the rest of it is called the main block elements or the normal block elements. So rows 1 and 2 plus 13 through 18, those together are called the main block elements. Okay? And then we'll talk about what happens here in here a little bit. But look at this periodic table. See right here? It says 57 through 71, 89 through 103. Do you see that on yours too? Or on yours you'll see it skipped numbers. That's because this right here, all this stuff down here, that all goes inside there as far as following this periodic law. But instead of having the paper twice as long, they just said, hey, look, it's like a carrot. Hey, we go right there. Okay. So let's go back to the notes here. Okay. So the periodic law, chemical and physical characteristics. Now, period is a row of elements, 1 through 7. Each row represents a new energy level. Okay? Number 2 here. Each row represents a new energy level. Our book doesn't have a page that shows how many electrons each energy level can hold, but it's basically the first energy level can hold 2. The second energy level can hold 10. 8 electrons, the second energy level can hold. And then the third can hold 18. And then the fourth can hold 32. And then after that it becomes a little vague because we haven't had elements that have needed to be defined by more. We do have actually, 7 energy levels that we use to define elements. But the total number held by each becomes a little vague. So note this. These are your energy levels here. I got a magical pen that's disappearing for some reason. But 1, 2, 3, 4 energy levels, and these are the total numbers of electrons. 2 in the first, 8 in the second, 18 in the third, 32 in the fourth. You should know that, because that's always true. It's how many electrons each can hold. Okay, so look at number 3 here. It says, as we go towards the edges, and when we say towards the edges, what we're meaning is towards the edges of the periodic table. So if we go towards the edge, so look at this, Donna, not including this right here, this gets more reactive as a trend. Okay, except for these over here. Do you know what these guys are called? Noble gases. These are called the noble gases. And do you know what nobility means? Kings and queens, right? And this name came from a time when we had kings and queens and they would not mix with the general population. So they called these noble because what they found out is those don't mix with anything. In other words, they don't react chemically with the rest of the stuff. They're noble. You have a question? And then over here on this side, it becomes, more reactive this way. Okay, so that becomes more reactive as you get towards the edge. Okay. Now here's another trend for you. As we go down in these areas, it becomes more reactive. So we're going to write that down. So these become more reactive as we go down. And then, how about on this side, what do you think?
It goes up.
As it goes up, it's more reactive. Okay, and we could talk about that later, or we might need that more to chemistry. Do you have a question?
Yeah.
Okay, so the question was about radioactivity. This reactive trending that I'm showing you is for putting chemicals together and they react with one another. Radioactive is when one chemical or element breaks down and emits radioactive particles. So this is not what we're talking about right now. It's not radioactive, it's chemical reactive. Okay. So, as we go further down in the notes, a group then is a column of elements. Okay. And this 4 main block elements piece right here, that is having to do with this stuff right here. So similar characteristics as you go down in your column. They should have. Now, this is an important part right here. Chalk this up and memorize it. If they're in the same column, they will have the same number of valence electrons. Okay? And I'll explain this right here. It says 1 has 1, 2 has 2, 13 has 3, 14 has 4. But before that, I want to make sure that you understand this. The definition of valence electrons. Okay, so the definition of valence electrons is, okay, turn that red to blue. The definition of valence electrons is this. The electrons in the outermost energy level. Okay? So it's the electrons in outermost energy level. Okay? So we're going to have to do some work with these valence electrons, so make sure you write this down and you'll understand what it means more. But for now, just memorize electrons in the outermost. Okay? And then for a group, they increase in reactivity as you go down. So if you look at this here, that would not always be the case. So it increases in reactivity. Let's kind of cancel off that last note about this piece here, and then I'll explain to you what happens. Over here, as you go down in this group, you do increase in activity, but over here, as you go up, you do increase in activity. So just like we said earlier, I'm going to have to modify those notes. Okay, now, look at this. Valence electrons. How many valence electrons does lithium have? 1. Because it's in group 1. See how easy that is? How many valence electrons does rubidium have? 1. It's that easy. How many valence electrons does carbon have?
14.
No.
4.
It is 4.
What?
Okay, and when we talk about the way electrons fill in chemistry, you'll find out that the outermost energy level will only, at maximum, hold 8 electrons. Okay? So, all you got to do for this side of the block of the transition here is just that number minus 10.
Does it start at 1?
What if it's 9?
Okay, so let's look at this. How many valence electrons does oxygen have? 6. How about selenium? 6. How about,
7. 8.
that's 8.
Couldn't see it. Your head was in the way.
Okay, so the question is this. How about these guys in here? Okay? Well, what we first start studying in chemistry is the main block or the normal block. So that would be rows 1, 2, 13, 14, 15, 16, 17, 18. So these will have different numbers of valence electrons according to some other rules and things that you will learn about in chemistry. So I won't ask you about valence electrons on the test of these guys, okay?
Wait, why did you?
It varies. But I will ask you about the valence electrons of any of these and any of these.
No, it's 2.
How about boron? What do you get?
3.
3. Okay, nitrogen.
6. 5.
5. So it really is that easy. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Okay. So there's 3 classes of elements on our periodic table. The first class is metals. Okay? So if you look on your periodic table, can you tell me how to tell if it's a metal or not? Well, in your book periodic chart, there's going to be a table or a key that tells you what colors are what. But generally, you can write this down. Metals are found to the left of the zigzag. Okay. Now you should be able to find the zigzag on your periodic chart. It's going to look like this. It's going to be right around here somewhere.
Oh, I found it.
Yeah, it goes on the beat. There you go.
It should be right around there. Should be the zigzag. Okay? And you can see it on that periodic chart. You can see it on yours. It'll just look like a thicker line. So what did our note said? It said, metals are found to the left of the zigzag. Okay? So left of the zigzag is going to be all this stuff. That's all metals. And then the next note says, non-metals are found to the right of the zigzag. So that's all that stuff. And then the stuff that's right on the zigzag, so these guys, the ones that are actually touching that zigzag, those are called metalloids. Metalloids.
That's like liquid and.
So they have, it's not liquid and solid, no. That's another thing. But these metalloids have characteristics of both metals and non-metals. So those are the first three groups you have to know about your periodic table for the test. Metals to the left, non-metals to the right, and right down the zigzag are metalloids.
Dude.
If you look at some of the characteristics,
Give it back.
metals are shiny and solid at room temperature. Although a lot of metals that you see will have oxidation on them, so you don't actually see the color of the metal. You see the color of the oxidated state of the metal. Most are good conductors of electricity and thermal heat. Okay, so if something's good conducting at electricity, it's also good at heat. And that's because of the nature of the valence electron structure. We may talk about that later. Metals are called malleable and ductile. Do you know the definitions of those? Malleable can be pounded into sheets. Ductile can be stretched into wires. Okay? So malleable and ductile are characteristics. Okay, so metalloids then are sometimes called semiconductors. They have properties of both. And then finally, nonmetals are non-conductors. They're to the right of the zigzag line. Most are gases at room temperature. They're not shiny, malleable, or ductile. Okay, so we're going to stop right here for the notes today. So let's remember that this is the end.